I am Naresh and Srikanth and this is Prasanna. And we are from SSN College 2021 to 25 batch. We made a simulation project for MHC internship program. So we made a presentation. Let's get into the presentation.
We are here to give a presentation on vending machine, which is implemented using embedded system. Over to Prasanna Karthikeyan.
So, the overview of the project is what are the skills we have acquired during the course of the internships and what are the knowledge we have gained. First, we have come to know about the embedded systems domain and we have learned the C programming and particularly embedded C programming. It really helped us to gain our knowledge and we help to increase our working on hands-on projects. This project was a creation of a vending machine using a big microcontroller, LCD display and digital keypad. Let's look further into about later. So the main goals of the internship are to gain practical experience in the field of embedded systems and to improve technical skills like programming, circuit design and system integration, to solve real-world projects and challenges by applying theoretical knowledge to it, and to learn about industry standard tools and practices in embedded systems development. So the description of the project is to develop a vending machine system and how the users will interact is first they will select the products and after they make the payments and after transactions are complete they will receive the product. The status is updated in the LCD display and there is an inventory management also included in this product which tracks the stock levels and the transaction process tracks the payment status of the users and there is also a mechanism provided for feedback which will be displayed in the LCD display. Then the main goal of the project is to create a user-friendly vending experience with efficient transaction handling. So first, why embedded systems? Well, embedded systems is particularly for dedicated functional. Basically, microcontrollers are specifically designed for perform dedicated tasks. So we don't need to use general purpose computers, which will take can accumulate multiple resources. So microcontrollers are used specifically to perform particular task, and the cost effectiveness. It similarly in general purpose computers there are a lot of usage of resources. When it comes to microcontrollers, the cost is reduced due to a particular efficiency. And the size and power efficiency, microcontrollers are small in size when compared to general purpose computer, and they consume less power when compared to general purpose computers. And real-time purpose, microcontrollers offer deterministic real-time response, and it's crucial for applications where the precise timing and control is required. They can quickly respond to external events and perform tasks in real time without any delay. Reliability and stability involves they operate in harsh environments and can withstand temperature variations, vibration, and other factors which can affect in in case of general purpose computers they have various effects and microcontrollers its ease of integration with various sensors, actuators, and communication devices, enabling complex functionalities in compact designs. And when it comes to security, it's critical concern. Microcontrollers can implement security features such as encryption, authentication, and secure load so that the data integrity and protection against unauthorized access can be ensured. And unlike humans, the microcontrollers have a predictable and consistent behavior, so the likelihood of errors or inconsistencies in its operation can be reduced. Now, the requirement of the project includes in the hardware components we require microcontroller, LCD display, digital keypad, electronic components for interfacing and control. When it comes to user interface, the keypad is used for product selection and transaction, and the LCD display for providing instructions and feedback to users. The functionality includes the ability to select products from the predefined list and payment processing functionality. That includes a inventory management to track the stock levels and dispensing mechanism for delivering selected products. Here we have done a simulation of the project which we have used Mplab Express which is a IDE and PicsimLab which is for simulating the micro.
The PIC16F877A is an 8-bit microcontroller made by Microchip. Here are some key details. Memory. It has 14 KB of program memory, 368 bytes of RAM, and 256 bytes of WEP ROM data memory. Peripherals. It features 33 input-output pins, timer, counters, and ADC with 10-bit resolutions, USAT, SPI, and I2C interfaces, and a PWM model. Clock speed. It can operate up to 20 MHz voltage. Typically runs on 5 EDC. Applications used in various embedded systems like industrial control, home automation, and automotive electronics. Development tools supported by Microchip's Mplab X IDE and other developmental tools. Why PIC controller? It is cost efficient. PIC controllers are affordable and integrate various functionalities into a single chip, reducing overall system costs. Compactness. They are compact and suitable for applications. Low power consumption. PIC controllers are designed to operate efficiently with low power consumption and making them ideally for battery powered devices. Versatility. They can be programmed to perform a wide range of tasks, offering flexibility in system design. Reliability. PIC controllers are reliable and can operate in harsh environments. Easy development. Supported by a wide range of developmental tools, making software development and debugging easier. Scalability.
So project design, this is our overall project design. And let me give a better view of this flow diagram to explain. So initially the machine gets started. So at the beginning it verifies whether it's all its peripherals and devices is working perfectly. Then it shows a welcome page in the LCD display, and it expects the user to press the RB4 button. Since we interface 6 keypad buttons, which is used to navigate and make the purchase and transactions and everything, which is used to handle every event flows for the user. Since we interface some 6 buttons, it is called RB0, RB1, RB2, RB3, RB4, and RB5. And initially, user is expected to press the RB4 button to move to product selection page from welcome page. So in our product selection page, user is expected to press either of the 6 button, which is correspond to 6 different products. Based on the button selection, the user can able to select the different products. So for example, as mentioned in the flow diagram, if the user press the RB4 button, it moves to the selection product selection page. Then it immediately waits for the user's input. If the user input is RB0, then it goes for product 1, and RB1 it goes for product 2, and it goes on. Then once the user selected with the product, then the product is checked for its stock. Whether the product is in stock, then it goes for payment page. If it is not in stock, then it again goes to the product selection page. So again the user is uh, prompted to select a product. Once the user is selected the product and the product is also in stock, user is provided with a payment page where you have to pay the um, cash, or he can also scan to pay the money. Once uh, he paid successfully, the product dispensation occurs. If the payment fails, the user is prompted to pay again, or user can also opt for declining the purchase. Once he declines the purchase, it goes for the welcome page again. Else, if the payment is success, the product dispensation will occur. Once the product is dispensed, again the welcome page is actually given. Through this way, our machine works. So let's go for a brief, detailed view of the development processes. Yeah, for developing this project, we first defined our requirements. Our requirements is to give a good user experience with a vending machine with all the functionalities like product selection and payment processing and inventory management. And the design hardware. In the design hardware, we use PIC controllers. So, specifically in PIC family, we use PIC16 F877A microcontroller. And since it's a simulation project, we use PicsimLab software to simulate the microcontroller behavior. And the PicsimLab software also contains a LCD digital keypad and some also other sensors also there for simulating for some other projects also. And we developed the firmware for this project using Mplab IDE. And we again generated our X file in the Mplab, and we loaded that file in the PicsimLab to simulate the code we developed. And once we iteratively developed the code and ensured that no bugs are in the program, we refined our code, and finally we validated the overall project using the simulation. And this is our oral demo. So this is our welcome page actually, the vending machine. So the user is expected to press RB4, so it is mentioned in the welcome page itself. And the overall procedure to make a purchase also mentioned here: select position and pay the cash to get the product. So let's go for a detailed view. So the first, the user is given with a welcome page. So it typically, once the user presses the RB4, this welcome page will occur. And once the welcome page is actually will be there for 2 seconds or 1.5 seconds. After that, he will be prompted to select the position of the product he wants to purchase. Once he selects the position by pressing this RB0 to RB5 button, any one of the buttons, corresponding product will be selected. So for that product, he will be prompted to pay the bill. Either you can insert the right amount of cash, or a QR code can be shown in the real time. But it is a simulation environment, so we actually had a to simulate this exact scenario. We had another technique, like if we press the RB4 button, it automatically makes the payment successful. If we press the RB3 button, it cancels the purchase, and if we press the RB5 button, it simulates the payment failed case. So the user is again prompted to pay payment section. Once the user make the payment successful, the product will be dispensed, and that page will look like this. So let's go for a very real demo in a PicsimLab software. We generated our X file in Mplab. So this is our code. So once we generated the X file, we use the PicsimLab simulator and we uploaded our X file. Then we start our simulation. Since at the beginning the user is prompted to press RB4 as mentioned in the LCD display. So this is our welcome page. And for a few seconds, 1 second it will be there, and again it prompts the user to select the position of the product. Since we interface 6 bouncy buttons, that is RB0, RB1, RB2, RB3, RB4, RB5, as I mentioned before. So I choose RB3. So which is nothing but Doritos. So selected Doritos at the position RB3. So now the machine prompts the user to make the payment. So in order to simulate the payment situation, we use these 3 buttons for 3 different cases. RB3 is for declining the payment and declining the entire purchase, and RB4 for successful payment, and RB5 for payment failed. So the user have to retry. So now I go for the retry case. So I am pressing RB5. So once RB5 is pressed, it goes for payment failed retry page, and again prompts the user to make the payment. No, if the user don't want to make this payment, or we don't want to take this purchase further, he can also cancel the purchase by pressing RB3. So the product is cancelled, and again it goes for the welcome page as I mentioned in the flow diagram. Now I'm again going to start the purchase RB4, and again it's giving me a welcome page, and I have to select the product. I'm selecting RB1. So I selected the dairy milk as RD1 position. Now I'm going to make my payment. So now this time I'm going to go with successful payment. So I'm pressing RB4. So the payment is successful. Now the product will be dispensed. And after dispensation, it again goes for the welcome page for the next user. Since in the code we actually hard coded the number of products to be 15, so that the same product can be purchased 15 times. Now after 15 times, it shows you the product is out of stock. But in real time, it will be tracked by using the exact product inside the machine by the administrator or the authority who is handling the machine. Is they will be setting these parameters. So this is our demo. So let's move to the conclusion. So for conclusion part, so in this project we learned how to use PicsimLab and Mplab IDE to generate our X file and to simulate the behavior of the controller in a simulator software. So in this overall internship, we learned the embedded programming using C and the PIC controller interfacing skills and also simulation techniques. And using this, we also learned the problem solving techniques also. So this is the project of ours for MXC internship program.